Good afternoon, dear students. I hope you all are in a pink of health, and it has been a long time that I was quite invisible to all of you. And today I have come up with a chapter called as Biomolecules for you all people. So my dear friends, first question will come to your mind that what are biomolecules? When we have a look at the term biomolecules, obviously bio stands for, bio means it's related to life, okay, or living system we can say. So those molecules we can say which are interconnected or which are related to the life, means they play some important role, okay, for the growth, maintenance, and they make a human being to be able to reproduce. So that's what the biomolecules are all about. So let's go for the definition of the biomolecules first of all. Biomolecules are the complex, lifeless chemical substances. My dear friends, when we go into the atomic world, first of all, we'll be thinking of colored charges, okay? Especially we talk of gluons, the colored charges, and later we move on to the stage called as leptons and quarks. And when we shift further up, we move on to the level of protons and neutrons. And further moving ahead, we come to the atomic level. And then further, one step ahead, we come to the molecular level. Now molecules can be either simple or they can be complex. So right from the colored charges, if I write down here, from the colored charges, then you move on to the leptons and quarks, then you shift on to the atomic level, and finally we come to the molecular level. When we start from the color charges till the molecular level, you will find out that all these entities are non-living, they are lifeless up to the molecular level. So further from the molecular level, if we move, we come across the term called as cell. So after the molecular level, we will come to the level called as cellular level, you can also say, means related to the cell. This is living, and all these like color charges, leptons, quarks, atomic level and molecular level, from here to here, from this point to this point, they are lifeless. And cellular level, everybody know it's living. So what does it mean now? It means very simple, like the life starts from lifeless substances. These are all lifeless substances up to molecular level. And after molecular level, you are shifting to the cellular level, that is the cell, and which is living. That means the living comes from the lifeless. So let's move on to the definition. You will find out biomolecules are the complex, lifeless chemical substances, because I told you that molecules are basically lifeless. So come here. Biomolecules are the complex, lifeless chemical substances. Means they don't have life. Molecules don't have life. But they form the basis of life. So you are moving from lifeless to life. So life comes into existence from the lifeless. Okay? Moving further, these biomolecules, when we talk of biomolecules, they not only build up living systems, that means they are not only involved in building up the living systems. Living system means the creatures, living creatures, plants, animals, insects and all, but also play very important role in the growth of living systems, means living creatures, in their maintenance, and will also give them the ability to show the reproduction. So now in nutshell, I would like to say that the biomolecules are lifeless complex molecules which form the basis of life, like growth of an individual, the reproduction process, all these are carried out by the biomolecules. I hope, my dear friends, you would have understood the definition of biomolecules, what they are. So let me just give an example of biomolecules. So have a look. Okay, that was all about the biomolecules. So my dear friends, let's take on the examples for the biomolecules. Examples of biomolecules. So my dear friends, we'll take on the first one as carbohydrates, and then we'll go for proteins. In case of the proteins, we will be having later enzymes and all those things. Let's talk about nucleic acids. Then we can have the things like hormones, lipids, vitamins. So my dear friends, when we look into these examples, you'll find out our first topic will be now carbohydrates. So we'll be going in detail about what the carbohydrates are all about. So first of all, we will take on the definition of what the carbohydrate is all about. There are two definitions for carbohydrates which you should remember. The first definition is the classical definition, the old definition of carbohydrates. So let's move on and talk about carbohydrates. Old definition, or you can say classical definition of carbohydrates. So how were the carbohydrates earlier on defined? Let's have a look at that. Carbohydrates were considered to be hydrates of carbon. So they were considered to be the hydrates of carbon. Okay. The general formula is CH2O Y times. So this is the general formula for the carbohydrates. In old definition of carbohydrates, my dear friends, the carbohydrates were considered to be hydrates of carbon. You can have a look here. This is the water molecule. It seems like, water molecule has been added to the carbon. So when you look here, you will find out that here the water molecule looks as if it has been added to the carbon. So we call it as hydrates of carbon. So, for example, if water molecule comes and falls onto the palm of my hand right here, so you can call me as hydrated Sufi, like water molecule has been added to me. Or if you add water molecule to any surface, it becomes hydrated. That is a term. So this was the classical definition of carbohydrates. So let us understand it by examples. Okay, my dear friends? I hope you might have written this definition. So let me erase it. I'll give you some examples of it. Have a look. If we talk about the molecule glucose, its molecular formula is C6H12O6, and we should know that this guy is a carbohydrate. So glucose is a carbohydrate, its molecular formula is C6H12O6. When we are supposed to write down this particular thing, as I told you previous time, what was the old definition? Old definition of carbohydrates was they are considered to be as hydrates of carbon. And what was the general formula? As I told you, it was CxH2Y times. This is the general formula. So let us understand whether this formula fits here or not. But we know that glucose is a carbohydrate molecule. So let us see in this pattern. I can write it like this: C6H2O. I know that hydrogen is 12 times here, so I'll multiply it by 6. So 6 into 2 is 12 and 6 into 1 is 6. So now this is exactly like this. You can consider this 6 as X and this one as Y. So now if you look here, you will find out that this water molecule looks as if it has been added to the carbon, which is actually not the case. But here, according to old definition, it looks as a water molecule has been added to the carbon. It has stuck onto the surface of carbon. It looks like that. So it follows this general formula, and we can consider it as a hydrate of carbon. Water added to carbon, so hydrate of carbon. That means our glucose molecule is a hydrate of carbon. It follows this general formula. So according to old definition, glucose molecule is a carbohydrate. So let's take on to the next example. Our next example will be of, let's suppose you have ribose molecule, or ribose we can say. Its formula is C5H10O5. That is the molecular formula of ribose. If I write it down, I can write it like this: C5H2O, then I'll write down here 5 times. So obviously this also follows the same pattern. Here the X is 5 and the Y is also 5. So it also looks like as if water has been added to the carbon, and it looks like hydrated carbon. So my dear friends, the ribose is also a carbohydrate because it follows the general formula, and so according to old definition, it is a carbohydrate. So after this, we will talk about the limitations of old definition. Once we discuss about the limitations, then only we can just go for the modern definition of carbohydrates. So my dear friends, please make a note of it and we'll move on to the limitations of old definition. So my dear friends, we talked about the old definition of carbohydrates, which was the carbohydrates were known as hydrates of carbon. Okay? And their general formula, as I told you, was Cx times and water Y times. This is the general formula according to old definition. But I will give you some limitations, like I have written 3 limitations right out here, which will prove that this old definition is not up to the mark. So a new definition has come, which is a modern definition of carbohydrates. So first of all, let us discuss about the limitation, why this old definition was discarded. Okay? The first limitation of old definition we'll talk about, that is Raminus and Deoxyribose are carbohydrates. These two are carbohydrates, okay, my dear friends? But how they are carbohydrates? Because of their chemical behavior. But do not follow old definition of carbohydrates. They do not follow the old definition of carbohydrates. So let us see. Let's talk about Raminus. What is the general formula of Raminus? It's a carbohydrate, but it does not follow the old definition. So let's see. C6H12O5. If you look at this particular structure, you will find out, let me try to write down it in this format. You will get C6H2O. Then I will write down here, we have only 5 oxygen atoms. So I can't write down 6 here because oxygens will become 6. I have only oxygen atoms here 5. So I have to write down 5 here. But the hydrogen atoms, 5 into 2 will be 10. But my dear friends, here you have 12 hydrogen atoms. And here you have only 10 hydrogen atoms. That means we have 2 more hydrogen atoms right out here. So if you look here at this particular formula and try to compare it with this formula, do you think that it fits into it? No. Because it does have 2 extra hydrogens, but it does not have. It should be exactly, if I remove this particular thing and from here to here it fits into this formula, but because of these 2 additional hydrogens, it does not fit into the formula. So what does it mean? That this Raminus is not a carbohydrate according to the old definition, because it does not follow the general formula Cx and Y and the water Y times. It does not follow it. So according to old definition, Raminus is not a carbohydrate, but it is a carbohydrate according to the modern definition, because you can have a look, its chemical behavior is that of carbohydrates. So this is the first limitation of old definition, that it says as Raminus does not follow the general formula, so it's not a carbohydrate, but in actual sense it is a carbohydrate because of its chemical behavior, which is similar to that of carbohydrates. Let's take another example. Let's take an example of now deoxyribose. The general formula of deoxyribose, or we can say molecular formula, that is C5H10O4 is the formula. Okay. Now if we open up this particular formula, we will get C5H2O. And here we have O 4 times, so I will take it 4 times here. Hydrogens will be 8. Okay. But here we have 10 hydrogen atoms. That means we have 2 extra hydrogens which we have to place outside. Now if we look at this particular pattern and this pattern, the general formula, as per old definition, if you look, you will find out it does not fit into this formula. That means, according to old definition, deoxyribose is not a carbohydrate. But when we talk of modern definition, it is a carbohydrate because of its chemical behavior, which is similar to that of carbohydrates. Okay, I hope you have understood the first limitation. Let's go on to the second one. Now look here, my dear friends, we have formaldehyde and acetic acid. They follow the old definition of carbohydrates. They follow the definition, but are not carbohydrates. That means, have a look. Let's take on formaldehyde. It should fit into this general formula, old definition I'm talking about. HCHO is a formaldehyde. It can be written as CH2O. 2 hydrogens are here, so CH2O. Now have a look. It fits into this formula. It's exactly similar to this. You can keep it here as it's 1 and it's also 1. So here X is 1 and Y is also 1. So it fits into the formula. Formaldehyde follows the old definition. So it should be a carbohydrate. It should be a carbohydrate. But it's not a carbohydrate. Why? What is the reason? The reason is that its chemical behavior, the chemical behavior of formaldehyde is not similar to carbohydrates. That means the chemical behavior of formaldehyde is different. Even though it follows the old definition of carbohydrates, but its chemical behavior is not similar to that of carbohydrates. So that's why it's not a carbohydrate. So this was the second limitation of old definition. Because old definition tells us formaldehyde is a carbohydrate, but it's not a carbohydrate. Another example I will take as acetic acid. Acetic acid. Old definition will tell me this guy is also carbohydrate. But when I look at its chemical behavior, it is not similar to the carbohydrates. So that means it's not a carbohydrate. So you have a formula CH3COOH. It can be condensate like C2H4O2. And this can be written as C2H2O 2 times. And obviously this also follows this general formula. My dear friends, formaldehyde and acetic acid follow the old definition. But I'm sorry to say, they are not considered as carbohydrates as far as modern definition is concerned, because the reason is that their chemical behavior is not similar to that of carbohydrates. Okay? So now let's talk about the last one, last limitation here. The last limitation is quite simple here. You can have a look. Carbon is not known to form hydrates. We were talking about the carbon. Okay, according to old definition, we were saying that carbohydrates are the hydrates of carbon. But you will be very much puzzled to hear that carbon is not known to form hydrates. Carbon does not form hydrates. So that means the old definition is completely discarded. We were saying carbohydrates are the hydrates of carbon, but they are telling that carbon does not form hydrates, which means the old definition is completely rejected. And I will give some time to have a look at this, and we'll go further after this. So my dear friends, we were into the classical definition or old definition of carbohydrates, and I told you that there are many limitations for that. So we'll move on to the modern definition of carbohydrates. So first of all, let's explain what it does say to us. Carbohydrates are the optically active polyhydroxy aldehydes or polyhydroxy ketones. So my dear friends, first of all I would like to explain you what is this optically active. We will be discussing about optical activity later in this chapter, but here I will give you the very crispy definition of optical activity. Poly term actually means here many, so we have here polyhydroxy aldehydes and polyhydroxy ketones. So carbohydrates are optically active polyhydroxy aldehydes or polyhydroxy ketones. So let us understand what do you mean by optical activity here first of all. See here, if I take on the sugar solution, let's suppose I have taken on the glucose solution. In this beaker, I have taken on the glucose solution. You assume, this is just a rough explanation. This glucose solution I have, through this solution I am passing on a particular monochromatic light. This monochromatic light is unidirectional light and it's oscillating, and I am passing this light, monochromatic light, through the glucose solution. And glucose is nothing but it's a carbohydrate and it should be optically active. What does it mean? What does it mean that it's optically active? I will tell you. When you pass on this monochromatic light, mono means one, chrome means color. One color means one frequency. Okay? Or you can say unidirectional. It's also known as plain polarized light. You can also write it as plain polarized light, PPL. When it is passed through the glucose solution, glucose is nothing but a carbohydrate. What happens to this particular light? It interacts with the glucose solution here inside. This light interacts with the glucose solution. So after interaction, it is being rotated. It's found that the light has been rotated. Now there are two chances. The first one is that it can be either rotated clockwise, okay, like this, or it can be rotated anti-clockwise. So let us see, this was the plane of the light. Now you can say that this light has been bent, it has been rotated. And this is done by the glucose solution. Glucose has interacted with the monochromatic light and it has bent the light. That is known as optically active carbohydrate. Let us suppose if this light passes through the glucose solution and it does not bend, that means glucose will be considered as optically inactive. But it rotates the light, so it will be considered as optically active. So a simple definition I would like to give here. When monochromatic light or plain polarized light is passed through the solution of a glucose, which is a carbohydrate, it rotates plain polarized light either in clockwise direction or in anti-clockwise direction. The glucose will mainly rotate the light in clockwise direction. That we will study further. So it is optically active. If it does not rotate, then it will be optically inactive. I hope you have understood. That was a crispy definition. So let's talk about this term now. Polyhydroxy aldehydes or polyhydroxy ketones. So when we talk of a term poly here, try to remember poly means many. Means two or more than two. And aldehyde functional group we have here. So let's talk of aldehyde. Aldehyde functional group is C double bond O H and one valence is free. This is aldehyde. Then you have ketone. Ketone will be basically C double bond O. And then you have a term hydroxy term. I will write down hydroxy. Hydroxy means OH group. It has one free valency. Ketone has two free valencies and aldehyde has one free valency. Means aldehyde is capable of making one bond, ketone can make two bonds, and OH group, which is hydroxy group, can make one bond. Valency is one, which is free valency right out there. So let's come to the definition. Carbohydrates are optically active, means they can rotate the monochromatic light in clockwise or anti-clockwise direction. Okay, and they are polyhydroxy aldehydes. Polyhydroxy means they have many. Poly means actually many. Hydroxy means OH groups. They should have many OH groups along with aldehyde. Means aldehyde should be also there. Or you can say polyhydroxy. Poly means many and hydroxy means OH groups. So they should have many OH groups with ketone. Many OH groups with aldehyde. Many OH groups with aldehyde. Okay. Here, many OH groups with ketone. So let's write down the structure for this. Okay, I'll take the time to erase this thing. I hope you have written. This part I will erase to draw the structure of glucose molecule. So have a look. Let's take an example of a glucose molecule. Have a look, my dear friends. It does have an aldehyde group. Okay, you can write it like this. So my dear friends, numbering will be always done from this carbon. So first carbon, this is second and this is third. Remember always the third carbon will have first, second, third, fourth, fifth and sixth. Total carbons are 6. The third carbon will have OH group on left side. You should remember that. The third carbon will have OH group on left side, and we know the formula, molecular formula C6H12O6. Okay, third carbon OH group on left side, and first carbon will be aldehyde. This is your aldehyde. Now the second carbon, fourth and fifth carbon will have OH group on right side. Second, fourth and fifth, they will have OH group on right side. But third carbon, you should remember, it has OH group on left side. And first carbon is aldehyde. This is your aldehyde. CHO. Now there remains now sixth carbon, that is nothing but CH2OH. And this valency is satisfied by hydrogen, hydrogen, hydrogen and hydrogen. Now my dear friends, if you look, it does have OH, 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 OH and OH. 1, 2, 3, 4, 5. So it has many OH groups. So I will call it as polyhydroxy because it has many OH groups. And many OH groups with aldehyde. Aldehyde is also there. So many OH groups with aldehyde. Who is having this? This is our glucose molecule. It has many OH groups in its structure with aldehyde. We call it as polyhydroxy aldehyde. So glucose is polyhydroxy aldehyde. And we should know that it's optically active also. That we can discuss further in this chapter, not now. So it's a carbohydrate according to modern definition. So your glucose molecule is a carbohydrate according to modern definition because it's a polyhydroxy aldehyde. Now the point here is that I would like to give one more example here about fructose, or we call it as fructose actually. So let's talk about fructose. So your pronunciation may vary. So it's fructose in actual sense. So let's have a look here. Fructose molecule. Formula is C6H12O6. The same molecular formula. This guy has aldehyde, but here we have ketone. Remember, ketone cannot exist at the terminal position. It has to exist somewhere in the middle. So I can't make ketone as a first carbon. I have to make ketone as second, third, fourth. But in case of fructose, the ketone is the second carbon. So we have second carbon as ketone. C double bond O is your ketone. Then what remains there? First carbon, second carbon, it becomes third carbon, fourth, fifth, and the sixth one. My dear friends, the ketone comes inside. Okay? So the second carbon is ketone. The first carbon will definitely become CH2OH. And I told you third carbon will have OH group on left side. And rest of the carbons will have OH group on right side. So here OH, and here we'll have H, H, and H. And finally, sixth carbon will be also CH2OH. So my dear friends, OH, 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 and OH. So many OH groups are there. So we'll call it as polyhydroxy. And it does have a ketone in it. So we can call it as polyhydroxy ketone. So your fructose molecule is also a carbohydrate. That means it is a polyhydroxy ketone. Glucose is a polyhydroxy aldehyde. And now point here is that both are optically active. That means if you make a solution of glucose or fructose, both will rotate the light. Okay? Now the question is that whether they rotate the light in clockwise direction or anti-clockwise, that we'll discuss later when we talk of chirality and optical activity in this particular chapter. Okay? So my dear friends, I enjoyed today's session and it was great to interact with you after a long time. May God bless you. Yo-yo. Take care of yourself. We'll meet the next day. Thank you.